Hello, and welcome to our Lokring sealed system repair presentation. My name is Jeremy Hedges, and I'll be guiding you through the repair of a GE refrigerator with a top mount freezer that utilizes R600a refrigerant. So as you can see, we have all our equipment, including the new evaporator, laid out onto our workbench. And the first thing that we'll do is we'll take an abrasive cloth and we'll clean any of the contaminants and oxidation off of the copper stubs. We're trying to preserve as much of the copper tubing as we can. So we'll clean all the way to the apex of the bend, where eventually we'll mark it with a Sharpie and make a cut using our LRSZ 120-degree tubing cutters. So we have to clean both sides, obviously. It's the same preparation that you would prepare for a brazing operation, except in this case, we're going to leave the factory braze joint intact. Since it's not leaking, we're simply going to remove the bend, leaving parallel tube intact so that our service connectors can then join the new evaporator to the pre-existing tubing inside of the unit. Here we're marking where we're going to make our cuts. Again, you just want to get as close to the apex of the bend as you can. You don't want to leave any of the bend because near the tube there's going to be a slight pinch, and that's going to cause ovality. So we're cutting where the tube is nice and uniform and parallel, and it's going to ensure that we have a nice fit with our service connectors. Here, Bill's using our LRSZ 120-degree cutters. Notice an overhand grip, which keeps his arm very nice and straight. Since these cutters don't have rollers, this is one of the techniques that'll help keep you perpendicular to the tube while cutting it. Don't cut all the way through the tube. It's only necessary to score it and then snap the remainder of the tubing off. This will also ensure a clean cut and that we have less burr or need for deburring of the tubing. On occasion, you may not have scored the tube quite enough, so just bring the tool back in, line the cutting wheels back into the groove you've already made, continue to cut, and then you'll be able to snap the tube off. Take a little abrasive cloth just to clean up any tooling marks or anything that may have remained. If you were barehanded, it'd be getting any oils off. Again, it's the same contaminant requirements that you are typically used to finding when you were performing a brazing operation. So the next maintenance we'll be performing is the removal of the faulty evaporator. Again, we're going to start with some abrasive cloth and clean all of the copper tubing inside of the unit. The factory brazes in this scenario were not faulty. This allows us to maintain all of the copper tubing that's inside the unit. This serves many advantages. One, it leaves you plenty of tube to perform your main repair. However, should you have an assembly incident or you had a faulty assembly, you still have some tube remaining for a second repair. This is always something that you try to teach and have technicians thinking about, leaving more copper tube than is necessary. Often, if you think outside of the normal brazing standard or location where you would braze, with Lokring, we can generally have a condition where we leave the unit with more tube than we started with. So again, this is beneficial for your main service that you're performing, or if for some reason something goes wrong, you still have tube to recover and create a second repair. And here you can see Bill's again using the LRSZ 120-degree cutters to cut as close to the aluminum stubs as possible. This again is giving us that additional copper tube that'll help us for our repairs. He scores through and cuts it away. We'll cut both sides, capillary and suction sides of the evaporator. And then after it's cut away, all we have to do is simply remove the old evaporator. So once we have the old evaporator out of the way, we can bring our new evaporator into the unit and install it back onto the mounting hardware. Installing it back onto the mounting hardware will make the assembly of the service connectors much easier. It'll allow you to push against the evaporator itself to make sure that you're maintaining insertion depth of the service connector while performing the assembly. Here you can see Bill is kind of preloading the tubes, very similar to what you do with brazing, where you want to get a slight bend so that they stay inside the coupler, in this case inside of our 0, 0 connector. Make sure we have all of the wiring out of the way before we get into assembling the joint. So in this case, since the evaporator inlet is towards the back, we'll perform that repair first. With the tubes preloaded and test fitted the connector, we can now go ahead and prepare for our permanent connection. So you'll put the connector on, apply some lock prep, rotate the connector. Now we'll go to the other side of the tube, slightly fitted into the connector, add 2 drops of lock prep, insert the tube fully, rotate the service connector to make sure the lock prep is coating the entire tube. Here, Bill's using his left hand, his static hand, to push the inlet to the evaporator against the evaporator itself to maintain that insertion depth. Once you've had a couple compressions of the hand assembly tool, you can then slide your hands towards the back to complete assembly where it's more comfortable for the technician. And as you can see, the joint is completed. On this connection, Bill is going to remove one of the rings. So the rings on our connectors are removable. They can pop off utilizing a pair of pliers. A twisting action very similar to opening a bottle top will remove them. We often do this if there's a bend near the connector because it'll actually shorten the profile of the ring. And in this case, it's allowing him to put a little extra pre-tension by shortening the body of the ring just from removing the ring itself. Again, he applies his lock prep, puts the connectors on, brings the other tubes in line. You can see the ring is a little loose. So now he's got the ring back away. He'll apply the lock prep directly to where the body and the insertion tube join, and then push the tubes back together. The ring slides right back into place. Rotate the connector, ensure good distribution of our lock prep, and again, bring your hand assembly tool into the unit, placing most of the force against your static arm, and you can slide back and begin the compression or complete joining of the service connector. In this scenario, Bill changed the direction of the tool. He switched from right-handed to left-handed because he has a lot more room towards the center of the cabinet to actuate the tool. After you've done those first couple compressions, the tubes are locked into the connectors and it's safe to move your position. So we're going to begin the compressor removal by cleaning the copper tubes just like we did when we did our evaporator installation and removal. Again, we're going to clean the copper tube where we're going to make the cut. So in this case, for the compressor discharge, there's adequate amount of tube, right straight tube, at the compressor stub itself. So Bill only has to clean fairly close to the original compressor joint. After he gets everything adequately cleaned, he'll bring in the LRSC 120-degree tubing cutters and cut the joint as close as he can to the compressor. Obviously, with the condenser or the outlet of the compressor, the epoxy coat that can be on those lines can take some time to get off, as are represented in this video. But now, as you can see, Bill's back with the LRSCs, and he's keeping that straight arm technique to cut into the steel line, ensuring you're getting a nice perpendicular score mark. But since we are dealing with steel, sometimes in a tight location, you can use a pair of pliers to actually twist the line and help snap that score, which is what he's doing here. And he's able to break it free nice and clean. Next, we'll go ahead and clean the suction line before cutting it. But if you notice this line, it has very immediate sharp bend as soon as it comes out of the compressor stub. So there's not enough tube present for a service connector to be mounted right where that bend is. So Bill has chosen to go directly under the apex of the bend at the first available straight portion of tube. So he's going to clean that portion and then make his cut accordingly. Again, keeping that straight, stiff arm motion, keeping his wrist parallel to the tubing itself. That's going to ensure a nice straight cut. And again, he picks up his pliers to help bend and flex the tubing and should snap right off. Looks like the compressor pan was interfering slightly with removal of that tube. And next we'll transition to removal of the dryer. So again, same process, cleaning our tubes to begin with. Again, you can see Bill's cleaning the tube as close as he can to the dryer. There's not much of the heat loop available coming out of the cabinet, so you want to maximize as much of the tubing as you can. Again, you can see how Bill really tries to maintain a straight perpendicular motion to the tube. Dryer snaps off cleanly. And then next we'll use capillary tube cutters to cut the capillary tube as close as he can to the dryer. So prior to installing the compressor or replacement compressor into the unit, we're going to go ahead and install a process tube right here on the workbench. So Bill's cleaning the new process tube port on the compressor with abrasive cloth. And now you'll notice he's popping the ring off. And the reason he's doing this is because this is a vertical down connection. He wants to make sure he gets the lock prep all the way at the top of the joint and coating the entire tube. Gravity's going to want to fight against you on this. So pulling the ring away lets you see exactly where you're applying the lock prep. Here for the top tube, gravity works with you. So he's applying it to the base of the tube and inserting it fully into the connector. You still need to rotate. You notice the ring slides right back up into place and he can complete the connection. Don't really need to maintain a pressure on the process tube. Gravity is keeping it against the internal stop. And you just keep going until both rings are in contact with the center stop and the joint's complete. So now we can remove the faulty compressor from our unit since we cut it away previously. And now we can bring in the new compressor with the process stub already installed. Now again, it wasn't difficult to install this process tube on this particular unit, but it was just nice to get it out of the way and perform that service on the workbench. So to complete the install, we'll go ahead and clean our compressor discharge and suction ports, ensuring to remove all of the oxidation from the copper tubing. So with all the tubes completely cleaned, now we need to bend our condenser or compressor discharge line. We also will need to reshape and bend the suction line. So Bill's going ahead and working with the compressor discharge to condenser. And he's placing the service connector onto the condenser line and then placing everything onto the compressor, checking for interferences. In this case, the condenser fan itself is an interference. So he just wants to pre-bend the tube, make sure everything fits nicely before we start our install. And he's going to move to the suction line, which as you can see does require quite a bit of reconfiguration of the suction line. And that's because the process tubes or ports on our compressor are in the vertical position now instead of horizontal. There's still plenty of suction line to allow for this repair, as you can see. It just takes some manipulation of the tube to get everything to fit into the connectors and line up with the compressor. Again, in this scenario, Bill's pulling the ring off of the connector, and you can see that it doesn't even want to go up the tube. And that's because, again, being so close to a bend, there's some ovality there. So by removing the ring off of the body of the connector, he's able to visually ensure and feel that he is in the internal stop and that that bend isn't binding on the ring itself. So everything is fit. He's got everything test fit, good to go. We have no interferences. So at this point, he can begin to make the permanent connections. So he's going to remove his connectors, get everything situated. He's going to pop another ring off the body. So now he has the compressor stub is placed the body of the connector. Both rings are separated. Again, since these are mainly pretty much another vertical down connection, he wants to ensure that he can see where he's applying the lock prep. So by pulling the rings off, you can do that. Now he'll lift the body up slightly off of the port on the compressor and apply the lock prep, and then lower the body back down. It's like he's going to add a little bit more and rotate. He must have had a little bit run down the process tube. Now he'll place his ring onto the tube and insert the condenser tube into our body of the connector. Again, lift your ring, pull the tube back, and apply some lock prep. So you're going to apply it directly to the insertion tube and against the body of the connector. And this is showing the another angle of the install. Again, rotating the body, making sure both tubes are inserted. He's going to lift the bottom ring up a little bit to get it to seat onto the body. And now he'll bring the assembly tool in. Again, in this case, his static hand is on top. That's allowing him to put pressure on the condenser tube and keeping it pushed into the compressor itself. That's one of our main failure modes is not maintaining insertion depth. So it's important to put that positive pressure on the tube and ensure that it remains inside the connector at all times. Again, after a few compressions, you can flip your tool over where you have more room to complete the connection. We're going to apply lock prep to the suction line now. So again, he's got the rings separated, lifts the tube so that he can vertical down connection, make sure he gets plenty of lock prep right at that interface between the body and the tube itself. And again, static hand is holding down on the suction line as he compresses the connection. Now that he's got some compressions, he flips it over where it's more comfortable and he gets much longer stroke on the tool because he's no longer hitting the compressor pan. And the joint's complete. And take a rag and remove any excess lock prep from the connections. So now that the compressor has been installed, we have one last component, our filter dryer. In this scenario, there was a defect in the capillary tube. It had a slight pinch, which allowed it to shear under manipulation. So we lost a substantial amount of capillary tube while performing this repair. So, to show the technicians in the field how to recover from this, we're going to do a capillary to capillary tube joining and actually add a small length. So, in this case, we have a 1.8 millimeter connector, so 1.8 NK-MS00 connector. They do have internal stops when we're talking about the straight coupler for capillary tube. And we have to be very careful. Just a drop, just get it to just on the tip of the applicator, then insert your tubes and rotate. Capillary action will draw the lock prep in, and you can close the connection. Just like brazing operation, if you applied too much lock prep here, it could be drawn into the end of the capillary tube, blocking it off. So again, the slightest application of lock prep on the exterior of the tube between the body and the capillary tube is all that's necessary. Now that we've extended the length of the capillary tube, we can now install the dryer. But we found that the dryer was extremely long as well. So we removed as much material off the inlet and outlet of the dryer as possible so that we could reduce the overall length of the dryer and ensure that it would fit neatly into the cabinet body. So with capillary connections, you'll first apply your lock prep onto the capillary tube side. As you see, basically Bill forms one little drop at the end of the applicator and then wipes it on the capillary. Now on the dryer side, we'll use more lock prep. So he's got about 2 full drops that he spreads out right there, and then we'll rotate and assemble the connection. Again, he's got his pinky is actually holding the capillary tube just to prevent it from backing out of the connection. And now we can complete the inlet to the dryer. And again, we're going to have another vertical down connection in this scenario, so lock prep application is very important. So Bill's going to go ahead and apply the lock prep from the horizontal to the bottom of the dryer. Rotate and make sure it's in place. And now he can apply the top joint. He's not going to pull the ring off since this is gravity will help as well as capillary action draw the remaining lock prep into the connection. There you go. And rotate the body of the connector. Maintain our insertion depth by pushing up on the dryer with our static hand, and then we compress the connection. Now we can move our hands out in a more comfortable position to complete the connection. And that's it. Connection is complete. Remove any residual lock prep from the connector. This will conclude our presentation of the Lokring joining system for the repair of the GE refrigerator with R600 as a refrigerant. I'd like to thank everyone for attending, and please, if you have any questions still remaining, please enter them into the chat box now so that we can address any of your questions and concerns. Again, thank you so much, and I hope you're able to take away some tips and tricks from this presentation that will help you to continue using the Lokring joining system. Thank you and have a great day.